Okay, so let's move towards question number 4. So the question number 4 is basically of transformations. And they say the transformation R denotes reflection in the x-axis. So we know when we have the transformation of reflection in the x-axis, our whole equation gets multiplied by minus, okay? And the transformation T is a translation of this, right? This is the matrix of that transformation. Now, this is the equation that we are given that we have to transform, and that has been transformed by the sequence of transformation R followed by T. So first we have to do the reflection and then we have to do the translation. So to do reflection first, we multiply this like the whole equation by minus, right? So that would become minus x squared after reflection. So this would be after reflection, right? And then translation. So we have horizontal translation to 3 units to the right? We have the horizontal translation of 3 units to the right. And when we're doing horizontal translation, we actually like put the opposite sign. So if this is plus 3, we would put minus 3 and whole square, right? And then if you're doing vertical translation, the sign would remain the same. So if it's minus 1, this would also remain minus 1. And the vertical translation is actually like added or subtracted to the whole equation. So this would be minus 1 after outside the bracket. Okay, so that's how you write it. So that is it for the part A. Let's move towards part B. So part B says find the equation y is equal to h of x of the curve with the equation this after it has been transformed by transformation T followed by transformation R. So yeah, so the only difference here is first it has been translated and then it has been reflected. So let's do the same thing. So y is equal to x minus 3 squared and minus 1, right? That's how you do it. That's exactly what we did above, right? We put minus 3 inside the bracket and we put minus 1 outside the bracket. Now, now we have to reflect, which means we have to multiply this whole equation by minus. So if we multiply this whole thing by minus, but the thing is, now this minus would be multiplied by this as well as this. So y is equal to minus x minus 3 whole square, and this minus minus would become plus. So this would be plus 1. That's it for question part, right? Part C. State fully the transformation that maps this into this. So we have g of x. So g of x was this, right? G of x is this, and then in order to convert this into f of x, so this is our f of x. So yeah, okay. So if we add, so as you can see, this first part is the same, right? This first part is the same, so we don't have to make any changes to the first part. But how can I make this minus 1 into plus 1? Can I add plus 2 to it? So if I add plus 2 to minus 1, that would become plus 1, right? Now, what would be the transformation that would allow me to add plus 2 here, right? That would be our vertical translation, right? Vertical translation, or a better way of writing it would be translation, and we can draw the matrix. So matrix would be this, and as this is a vertical translation only, not a horizontal one, so we would write 0 in the movement of the x direction, and in the movement of the y direction, which is the vertical movement, we would write 2, right? Positive 2. That is it for question number 4. Let's move towards question number 5. Show that this equation may be expressed as this, right? Where a and b and c are integers to be found. Great. So we have to make this in terms of cost, right? So let's see. Hmm. Um, can I okay, so let's first make the denominators the same, right? Let's first make the denominators the same. So that would be, okay, let's first convert this 10 because we don't have 10 here, right? So we can convert this 10 in sine over cos, right? Sine x over cos x plus 2 divide by Sine x is equal to 0, right? And then this cos x can go in the numerator, so that would be plus 5 cos x, and then sine x in the denominator, and plus 2 over sine x. Okay, great. Now we can make the denominators the same. So this, as you can see, this 4 sine x don't have the denominator of sine x. So we can multiply this by sine x in the numerator as well as the denominator. So yeah, that would become 4 sine x, sine squared x plus 5 cos x plus 2. And the whole denominator would be sine x, right? And then it would get multiplied by 0, and then um, there would be nothing left in the denominator. So that's what we are getting. Now we have to make this in terms of cos only, right? So can we convert the sine square x into cos square x? Yes, we know a very good identity that has the capability to do that. So we know that sine x squared plus cos x squared is equal to 1, right? So if I have to make sine squared x a subject, I would say 1 minus cos squared x, right? So I can just substitute this by 1 minus cos squared x plus 5 cos x plus 2 is equal to 0. Now I can say 4 minus 4 cos squared x plus 5 cos x plus 2 is equal to 0. And if we write that final, so let's move everything towards that side, right? So we can have our cos squared x is positive. So 4 cos squared x minus 5 cos x, and then 4 plus 2 is 6. And if we move that to the other side, that would become minus 6 is equal to 0. That is our final answer. Okay. Okay. Hence solve this. So we have to solve this exact same thing. And we know that this can be rewritten as this, right? So we can say 4 cos squared x minus 5 cos x minus 6 is equal to 0. So you have to solve this. And to solve this, make sure your calculator is in the degree mode, not in the radian mode. Okay, so first of all, let's substitute this cos x by any variable that would be easier for us to understand and comprehend, right? So we let cos x be u, right? Let's substitute it with u, so it would be easier for us to comprehend what's going on. So 4u squared minus 5u minus 6. So instead of cos x, I've just written u here, right? Is equal to 0. So that is our quadratic equation. Now you can solve this quadratic equation using middle term break, and then you can check your answer with the help of your calculator. Okay, so that would be u minus 2 and 4u plus 3. Okay, so that is what you would get after factorizing. And so your u would become 2 or minus 3 over 4. So these are the two values of u are getting, of u that we are getting. And we know that u is basically cos x. So we can just write that as cos x is equal to 2 or cos x is equal to minus 3 over 4, right? Yep. So now we have to make this, we have to find the basic angle, right? So the basic angle would be cos inverse of 2. But the thing is that that is not valid. You don't have a cos inverse of 2. That is not valid. That is not possible actually. Why? Because the maximum value of cos in the graph is your 1, right? Cos cannot have the value, cos x cannot have the value above 1. So this, we can reject this, right? This is not a valid solution. So our only solution left is this. So to find the basic angle, we take cos inverse of 3 over 4, right? So cos inverse of 3 over 4, and make sure your calculator is in degree mode. That would be 41.4, right? Then we make the 4 quadrants to help us visualize what's going on better. So let me just make this whole thing a little smaller so I can fit my answer. Okay, so I know that my cos x is negative, right? It's negative 3 over 4. So I have to I have to take the values. So first of all, let's see our range. Our range is from 0 to 360. So we can make the full revolution, right? And so we know that cos is positive in here. So all science teachers are crazy, right? Okay, so we know that all of these trigonometric, whether that's cos, sine, or tan, all of these ratios are positive here. So, but our cos is negative, so we can reject this quadrant, that our answer wouldn't lie in this quadrant. And we know the only sine is positive here. So we can use this quadrant because we know that cos will be negative here. So the basic angle here would be 41.409, or you could just say 41.41. And here tan is positive, right? So we can say that cos is negative here. So that is also two acceptable quadrants. And as we know that cos is positive here, so we would reject this quadrant. So, okay, so we have to find these two angles now. The first angle is this, and the second angle is this. The first angle can be found by subtracting the basic angle from 180, which would give me 138.59. And if I estimate to one decimal place, that would give me 138.6. And then I have to add uh, this basic angle to 180 in order to calculate this angle, right? So that would be 180 plus 41.4, that would be 41.41, right? So that would be, that would be 221.4 to one decimal place. So that is it. These are our two answer, right? Degrees. So these are in degrees.